One of the ideas that we had was just running through some of the APIs that we had to add to the web platform to make this phone work. We can dive into one of them later on and actually show you how it's implemented in the UI. But if you guys have any specific questions, I think that will be much more interesting. So if there's any kind of API that you guys are interested in learning about.
I have a question about news and something. For example, is this the platform ready for reading RSS and Atom formats? For example, if I have some feed and put it it will be automatically read, or
how would you do this in a web app right now?
First of all, I would parse the XML, and after I would put in the web view or something like that.
Right. Well, a web view, like what kind of web view? I mean,
I'm sorry. I just get the HTML content,
right,
and show.
Right. That's exactly how you would do it. Like developing for the phone is exactly like 99% of the time. It's exactly like you're developing a website. You're developing a web app. There's no you can basically, and that's a great thing. Everything you do right now for a website, you can just transfer 100%. Yeah, feel free to please ask questions, and if you guys want us to look at some of the source code for specific functionality or something, we can do that. Or if you guys have specific questions for your use cases, we can do that too. And yeah, go ahead.
The question is about the JavaScript performance. I downloaded the Firefox browser for the Android. It's really fast. Good job. The phone will have some improvements in the performance over the Firefox mobile, or will be just the same?
It will be at least as good. For a lot of things we can do better because we don't have to the Java pieces in between. Something that Andreas was mentioning. So the question is, I should repeat the question. The question is basically how's the performance, in particular the JavaScript performance, going to be on the phone versus, for instance, Firefox on Android. So Firefox on Android is already really fast in terms of JavaScript performance. I think we're definitely faster than the stock browser, but I think we're also faster than Chrome, I think. And so there's an ARMJIT, the same ARMJIT that's available on the phone. And in terms of graphics, so JavaScript is I don't think will be much of a problem. I think what could be more of a problem is things like garbage collection and things like that. But they're a problem everywhere. They're a problem on desktop. They're a problem on the phone. On the phone, it's just everything gets multiplied by 10 or so in terms of performance.
And feedback like WebGL and
yeah. So there's really two parts of making performant web apps. One is the JavaScript side, and the second one is the actual rendering part. On the JavaScript side, we are using the same JavaScript engine that's in our Android offering. And as Philip already said, the performance of that tends to be actually very good these days. In many cases, JavaScript today is only a couple of factors slower than natively compiled C++ code. In fact, Mozilla's research group has a project where we can take arbitrary C++ code, like in a game engine, and translate it directly to JavaScript. And the slowdown is a couple of factors. It's like 5 or 6x slower or so than the directly compiled code, but that's getting really, really close. So JavaScript performance today is often actually not the performance problem if you see something being slow in a web app or a game. That usually is more on the graphics side. And there actually we have quite a bit of an advantage over a stack like Android. Because in the case of Android, there's a couple copies in between and Java code and a bunch of other atrocities. And we bypass that directly. So we have, for example, a WebGL backend that renders directly onto the frame buffer. So on the phone, you have a demo here of a skull, like the 3D WebGL demo.
So this is a demo. I don't know if it rotates. No, it doesn't. But this is basically, I think we're running this at like 60 frames per second. This is a 3D rendering using WebGL. And
So it's a complex 3D scene that you can render very efficiently with WebGL, which is JavaScript and WebGL.
And this is a website. This is just JavaScript and HTML. So and what Andreas was mentioning, people at Mozilla for research purposes are taking like game engines, they're converting them from C++ to JavaScript, or compiling them basically using WebGL, and they run in the browser. You can play like a first-person shooter game or something like that, and they run perfectly at 60 frames per second. They might not run as fast as natively, but after 60 frames per second, you stop caring. At some point.
The tool for this is called mscripten, emscripten, and it's open source as well. So if anyone has games that are written in C++, especially like game engines or physics engines, you can pretty easily translate those to JavaScript. And then they run on this phone, but then of course it's JavaScript and WebGL, so they actually run everywhere. So we're really trying to help game companies and other vendors of kind of legacy C++ applications to bring them to the web, and with that bring them to this phone. Okay.
Cool. Yeah, thanks. Good question. Okay, yeah, so let's run through some of these examples, but again, feel free to interrupt us and ask specific questions, and maybe, if you think of any use cases that you might have. Yeah, one of the, and some of these are just showcases, like web telephony is, how we, traditionally within a web app, within a web browser, you have a lot of ways to communicate with other servers using HTML and HTTP and XML and so forth. One of the questions was RSS, for instance, but a lot of the device access isn't there, and so this is the kind of stuff that we had to add. And so a lot of these APIs are being added to the navigator object. And so when you're in JavaScript, that's basically a lot of the times where you find the new capabilities. And so, for instance, for telephony, so we have navigator.mos telephony, and as you can see right now, this is prefixed with mos because it's for now it's a prototype API that we've spec'd out, we've invented, we've put out there, and at some point, hopefully, once we go through a standardization process, etc., a lot of these APIs will we will be able to remove the prefix, and then they will be implemented in their final incarnation. And so here's some of the things you can do. You can, like, for instance, query whether the telephone is muted, or whether the loudspeaker is enabled. These are some of the sort of stateful properties. You can make, there's a nice typo there, but yeah, you can make a new phone call to a number, and then you receive back a call object. And so a lot of these APIs that when we're dealing with device capabilities, they somehow communicate with a lower layer. And so a lot of times when we abstract these capabilities, we basically hand you back an object that represents a request, or that represents the action that you're doing. A lot of the times this is actually what we call it a request. And in terms of, and for telephony, the abstraction that we chose that makes the most sense is a call. And so on this call, you can listen for state changes on this call object. And again, this is a pattern that kind of goes through a lot of these APIs, that then you listen for events on these requests. As for instance, state changes in the hardware layer. So, with the battery API, you listen for changes in level changes or something like that. And so here you see, like, you can listen to all state changes. So that way this function will be called for whenever any state changes occur, and then you can look at this is actually wrong. This should be call.state. I should fix that. Let me fix that right now. Event.target, and in fact I can make this a bit clearer. I can say var call equals event.target. In case I don't have access to the call right there. But I mean, I have the call from the upper scope in this case. But yeah, so I mean, this works like a lot of like events from HTML and JavaScript. You get events. You get the same kind of event behavior that you get, and so event.target is nothing new if you've done web development, and these are things that you can look up on MDN and things like that. And so yeah, so here you can listen for all state changes, or you can just say I just want to know when the connected state happens, and then you can basically you just get called then, and then you can update the UI or something like that. And so the dialer application on the phone is uses these exact event handlers, and then you could also, then we have one special event handler on the telephony object itself. And that's for incoming calls. And so this event handler is called incoming calls, and so forth. So yeah, and then you can also there's another event called calls changed, and that's when you have multiple calls coming in. For instance, is very useful. So then you can sort of hold this call and answer this call and stuff like that. And so the dialer uses all these events, and it's actually quite fun reading the dialer source code. It's up on GitHub if anybody's interested, or we can, if anybody has any specific questions, we can look at it also together. Yeah, an API that I think is a lot more useful for more sort of widespread applications is SMS. And I should have really reviewed some of these typos. But yeah, so like telephony and like a lot of these other APIs, there's this API is also available on the Navigator object, and it's very simple. This is how you send an SMS, and what actually happens is when you do this. What should also maybe be explained here is this action, this function returns a request. So which basically represents the fact that you want to send this SMS, and then you can listen to events on this request to find out whether the sending the SMS was successful or not. Because it might take take some time for the radio to actually send it, and for instance, if you're out of service, or if you're not registered, or for instance, if the service provider rejects the SMS, you'll then get an error event. Same with like incoming calls. For incoming SMS, you can listen to on received, and this function will then be called whenever an SMS gets delivered, and you can then look on the event object to get the message. Another interesting API is, for instance, the battery API. So things like, and again, it's much like all the other APIs, it's available on the Navigator object, and you have all these different event listeners, level change and charging status change and stuff. And so the status bar in Boot2Gecko right now in FirefoxOS is implemented that way. It just basically listens to these changes and then displays different kinds of icons. It's very simple. It's like, it's a couple lines of code, and it really shows that, using these sort of event-based JavaScript things. I think all it does is basically change the CSS class based on the event that it fires, and you realize like you can actually write like these UIs that react based on device changes in just a couple of lines of JavaScript. And you look at Gaia sometimes and go like, wow, that's so simple. And it's kind of cool. Vibration API, same thing. It's available on the Navigator, and you can look up the details on MDN again, but you can make sort of patterns if you want to. If you want to like go brr or something like that, and it's all in milliseconds, I think. Context API is really interesting. I think like if for instance you want to write like a chat application or yeah, for instance an internet chat application, and you want to be able to synchronize your friends list with your contacts list or something like that. Like one of the things that I always kind of miss, for instance, and I wish that somebody would write this for FirefoxOS, is like an integrated chat, SMS, and Messenger app, so that I have like, because I don't really care, and I don't remember when somebody said something to me, like whether they wrote an SMS or that they sent me a chat or something like that, and I would kind of like it all to be in one thing. And I think like with these APIs, it would be so easy to just put it all in one application. And so Context API is like is a really good example for this. And again, it's available on the Navigator object, and so you can. This is how you create a new contact, for instance. And again, anything that sort of deals with the lower level, any kind of action is usually, because it's asynchronous, is usually represented using a request. So if I ask the system to save a contact for me on disk, I get back a request, and then for most of the time I would expect it will be successful because I'm just saving something. But you know, if the disk is full or whatever for whatever reason, or if my data was invalid, I don't know, get an error. Settings API is an interesting bit. So here we again navigator.mouse settings available from the Navigator object, and then here we basically have a way of manipulating any kind of setting that's available on the phone. And here we wanted to show a little bit of how it's actually implemented.
Maybe you can switch the microphone for a second.
Sure. Yeah.
So if you go back to the slides for a moment, an interesting piece about this API is actually that it works basically by transactions. So you can update multiple settings at the same time before they become active. So the basic idea is that, again, everything on this phone that you can do, you do through the web API. So the settings, if you have the phone device here, the actual settings app itself is also implemented in HTML5. So if you go in this app here, there's a little like settings dialog here. So all these are traditional settings stuff that you can like configure your Wi-Fi or device settings and sound, all these things. We need an API where you can store all these settings and you can change them. And this is what this API is for. This is actually one of the privileged APIs, and towards the end of this session here, we'll talk some about what it actually means that you have a privileged API and how you have to package your application for that. But for now, let's just assume that this is some privilege that you can get through a marketplace, that you are able to access directly the device configuration. So you have this settings object you can find on Navigator, and the first thing you do is get log, which really means that you would like to go and make a change to the setting, to the settings state. And that returns you an object that's basically a request, where you ask for permission to change settings, and you can do a bunch of operations like set and get operations on that request. And when you're done with that request, that's when the actual operation executes. So what we're doing here, we're setting the background to an image. This would set the background of the home screen to a different background image. You actually now look at the somewhat more interesting case, the actual source here. So this file is from the Wi-Fi part of the configuration. So actually, could you pick up the index of HTML? Oh, sure, HTML code. So I'm going to show you some code now from the settings app that is showed you on your phone device. If you want to look at these examples at home, a little bit later on we will show you where all the sources are. So this is basically part of the settings app. And inside the settings app you can find index of HTML, and that's the main document that's being loaded. So you see here basically the actual HTML code for defining these settings here. And if you scroll down a little bit more, you don't want to find the Wi-Fi setting. Except for check. Oh, there we go. All right, so there's a checkbox here under Wi-Fi connectivity. You see here Wi-Fi enabled is the item of the checkbox, and in there is the right next to the little checkbox that can be checked or not. So we define this in the HTML document, and we will see in the code in a moment that we will do some CSS selector matching on Wi-Fi enabled and the actual checkbox state itself. So if you switch on to the JS code that goes with this file, so here now you see the actual CSS matching here. So G Wi-Fi checkbox, G is for global. So this global variable here picks up the right figure selector, the Wi-Fi enabled item in the settings dialog, and the actual input checkbox that goes along with it. So here's the actual code then that we will execute on that. So what we say that every time that changes, so I go and tap on it, I'm going to execute this event handler. I'm going to do settings.getLog, as you have seen on the slides, and I will set the setting Wi-Fi.enabled to this.check, which is the actual Boolean state of the control. So this kind of shows you that these APIs you're displaying here to you on the slides, and they're not just like some magic APIs that we came up with and want other people to use. We're actually using all these building blocks to build the actual functionality of the phone that you're seeing here. All right.
I have a question.
Yeah, please.
So do you know the reason or the reasoning that Google, when some applications are attempting to change those paths, this application redirects to the actual Google path panel?
Yeah, so the question was why, and is this for Android or?
Android.
Yeah, so the question was in Android, if you are trying to change a setting, why instead of allowing to change the setting, you are kind of bounced into the settings app where the users are also changing the setting. So that's actually a very interesting distinction that we are making as well. As I said earlier here, there's a certain permission or security piece associated with this. So if you want to directly access the settings of the device, you have to actually be a packaged application. You have to be shipped to the device via a marketplace. There's certain restrictions. We have a user review your code. If you want to update your code, you have to go through our review process. The reason you have to do that is because the settings API is actually very powerful. Amongst others, you can go and not just change whether the Wi-Fi is enabled or not, you can also configure the Wi-Fi. So you could, for example, go and enable the Wi-Fi behind the user's back, or you could go and change the password settings, or you read back a Wi-Fi password.
Enable the Wi-Fi tethering.
And then enable Wi-Fi tethering. So there's a bunch of malicious things you could do. So this is one of the APIs. If you want to use the raw API directly, you have to go through a certification process. And there might be very good legitimate use cases for that, right? Maybe you have a better settings app than we made one. So all the apps we are shipping on a device by default, in many cases, maybe like someone comes up with a better one, or maybe it's like a really useful shortcut on the home screen where you can very quickly enable or disable some feature. So we want you to be able to build these things, but if you're building, for example, a newspaper application, and you want to allow the user to like kind of set the brightness settings, you don't really want to have your newspaper application or newspaper reader go through a certification process just because you would like to help the user to do this like one feature directly from the app. So in these cases, usually there's a fallback mechanism. That's actually very similar to what Android does when you try to change a path. So for example, you can use Android. You can bounce the user with an intent into the settings app where you bring up the right dialog to change something, but then the user has to go actually and make the change. The difference here is that you are no longer need the privilege. You're not really doing any change. You can't directly access the settings. You can instead call the settings application so the user can more easily do whatever changes there. This is very similar for a couple other device capabilities. For example, taking pictures. That's actually a highly sensitive operation, accessing directly the video stream coming from the built-in camera, because you could easily spy on the user, right? If you're like the Facebook application, you would like to be able to upload pictures. So that's a great use case. Users really want that, but I'm not sure you really would like to have access to the raw camera stream, because then you can just kind of randomly in the background turn on the camera and spy on the user. So instead what we do is that we have a camera application which is accesses streaming video, and it allows the user that functionality to take pictures, and you can call the picture taking application, which is certified by us, with an intent, and you don't have to be a certified application for that. So you can simply say in intent, take a picture. And then whatever the registered applications are that know how to take pictures, one of those will be swapped to the foreground. The user can go ahead and take a picture, and then the picture is handed back to the application that requested this. So the big advantage basically is that you don't have to be a certified application to use a lot of device functionality if you go through the built-in applications. But at the same time, if you have an application that really wants to streaming video like Instagram or something like that, then you can definitely have this capability. It's just a different security model behind this. Make sense?
Yeah, so in the case of the preferences settings, so I don't know if I missed that part, but are you also intended to have the intent model for the settings as well?
We support the intent model. It's called web intent. It actually works very, very similar to the existing models, especially in Android. So this is a standard that's being worked on right now, and it defines a range of like built-in intents, and there's also a way for applications to reinstall entire new intents. So it would make a lot of sense. I'm not exactly sure right now whether they actually have an intent to drop you in every single settings pane, but it makes a lot of sense to do that. Exactly for the reason that you might want to change something in the settings, or you might want to help the user to quickly change something without really yourself picking up the privilege to do that. But that's exactly the intent of this system, is to allow you to kind of access the different parts of the system by expressing what your app needs without having the right to actually do it directly yourself. Okay, any more questions?
Yes,
Yes,
it's made on the same street here. Will Mozilla develop only the most basic apps like configuration settings and the camera, or it will also develop like mainstream apps like Facebook or Twitter?
So the question is whether Mozilla is going to only develop the kind of core applications, as you call them, like a dialer or a calculator or camera access, or whether we'll also do apps like Twitter and Facebook. So first of all, the reason we are doing things like the dialer right now, or like the camera, is that they're core applications. We really need them. Nobody else is building them right now. So there's a certain set of minimum applications that if you want to bring a smartphone to people, they expect those applications. I think right now we have like 17 applications we consider core. That's like the camera, settings, browser, these kind of things. And that's why we're developing those directly ourselves. Now, we are very much interested in having Facebook and Twitter on this phone. However, we're actually not building those applications ourselves. And here it really helps us that we have an HTML5-based ecosystem, because actually we did not have to build a Facebook and Twitter application. If you take these developer phones we have with us and you go to Facebook with it, Facebook actually already works very well on this device. And it already did so pretty much from the very first day when we brought up these devices. So if you go to Facebook, it's probably like 95% of the experience of the Android native Facebook experience. Facebook has already a pretty powerful web application, since many phones that they are targeting are not Android or iOS, and they cover those with a web app. So these existing web apps for Facebook and Twitter we can very easily pick up and integrate on our platform. Now there's usually quite a bit we can improve there. So on the one hand, we have simply more capabilities already existing in a platform that are not really necessarily available in other systems. So for example, we have streaming video. We have better picture taking APIs. So these are things that we are reaching out to companies like Facebook and Twitter, help them understand where the direction of the web is going with these additional APIs and capabilities, so they can enhance the Facebook and Twitter apps to directly support these capabilities. A second area where often we try to help optimize applications is actually offline use. So if you take the Facebook application, which is a pretty good example, due to the way Facebook structures its code on their servers, it's right now mostly completely uncached. So every time you go to Facebook, a bunch of code has to be re-downloaded all over. And that's not very favorable for markets such as Brazil that have relatively low bandwidth data networks.
Ironically, the same thing is true for the Android app.
Yeah.
So
the Android app usually is internally built that's also an interesting point to bring up actually, that a lot of the apps in Android and iOS these days are also built with HTML5. So that's one of the reasons that we can have so many apps right from the beginning without having to do a lot of effort in building these apps. That's exactly why we think that this system is going to be much more successful than other attempts. If you look at proprietary systems, we have two large existing ones. We have iOS and Android, and people build hundreds of thousands of apps for those systems. But it's very difficult for a third party to come in with a new proprietary ecosystem. If you look at what Microsoft is trying to do right now with Windows Phone, they're proposing a third independent, different proprietary system. It's like C# and a bunch of Windows APIs. And you can kind of observe in a marketplace how much they're struggling to convince people. Because if Microsoft wants for a Windows Phone a Facebook application, they have to either convince Facebook to write it, or they have to write it themselves. That's exactly where we don't have to do that, because we are using the web as our ecosystem. So all we have to do is take the existing Facebook app and make it a little bit better, add additional support, or help Facebook to add additional support for device capabilities, and also help them to do the offline caching part better. Offline caching tends to be usually the biggest problem for web apps these days. That they're often, people just kind of take a website and adjust the form factor, That's a good step towards a web app. So if you do that, you can put a manifest with it and you can put it in the marketplace. That's a good first step. But basically, immediately your second step should be, how can I reduce bandwidth use here? How can I reduce the amount of code I have to download, or amount of assets I have to download every time the user goes to my application?
Also, we will also talk, I don't know if anyone already asked that, so if they did, please just tell me. We will talk specifically about web browsing using Firefox on the mobile phone, and I'm telling you why I'm asking you that. If you take Windows Phone, for example, Internet Explorer is doing a terrible job there. You can hardly navigate on the internet using Internet Explorer. Also, Opera is not doing so well. But on the other hand, when Amazon released the Amazon Fire, they released that new technology to the mobile web browsing, that they pre-cache many pictures on their servers and then stream just a small package. So after all, the experience would be much better. Do you have anything special for the Firefox on your cell phone?
So the question was how we are trying to optimize the browsing experience on these devices. And the specific example that was brought up is the Amazon devices that do like server-side caching of content and kind of streaming, downloading, and translation of content. So there's actually a couple of parts to that answer. So first of all, if you look at mobile devices, people actually tend to use apps a lot more than the web. There's a specific reason to that. The web is often not as optimized for mobile for a touch screen and a small screen size as apps. So we actually think that even on a web-based smartphone device, people will often be able to create web apps that will be a better experience than if you just go straight up to the website. So we would expect that as content is moving towards being more webby on the mobile space, you will see a lot of people making web apps using HTML5 and the web app manifest, and using a lot of offline caching. In the end, that is the much more powerful approach. If your app is cached locally and all you do is like stream down the pictures, and we have good platform support to officially download pictures in the background, sort of workers and all the other things you might talk about today, then I think you get the benefits of these kind of like streaming protocols and optimization. The reason we are not doing exactly that approach Amazon is taking, or actually Opera Mini is doing the same kind of like server-based approach, is that it has a lot of very tricky privacy implications. So let's take the Amazon example. As you said, what they are doing, they basically have a server farm, and every time you surf to a page, they actually go and download a page for you, and then kind of process it and give it to you. And we don't think that's a particularly good model for a couple of reasons. First of all, Amazon knows every single page you go to. And for Mozilla, privacy and security are very key parts of what we are, the foundation, and the products that we make. So for us, it's very important that we protect your privacy the best we can. This is particularly important for encrypted data. If you have like a channel to a bank, for example, where you use an HTTPS connection, you don't want anyone to be in the middle of that. You don't want anyone to be able to read those, what the data is being exchanged. If you want the server side to somehow prepare the content, then we would have to sit in that connection. Now, as far as the future is going, really, we think the best way of doing that is we should go back and analyze why Amazon was able to get an improvement with the technology they did. The reason for that is that HTTP as a protocol is it's more than 10 years old. It's not very suitable for the kind of networks we are using here in the mobile space. Like 3G networks are really terrible with HTTP due to the way latency works on these networks is different from the way that wired networks work. So instead, what we should be doing, instead of like putting servers in between and having like companies spy on your web traffic, we should instead revisit the protocols of the web. And that's exactly what Mozilla is participating in. So one of the technologies that was proposed to kind of alleviate this problem is Speedy, that Google put forward as a protocol extension. Speedy is basically an improved HTTP that works much better on high latency networks. And there's a bunch of other improvements like that, like the image formats and compression formats that are possible. And Mozilla is really focusing on exactly that. We want to fix whatever is broken in the web, not like build this like server-based bypassing the web. The reason we can do that is that we are a web company. Like we are one of the companies that engineer the web and have the ability to really push new technology into the web, along with like the Microsoft and Googles and Apples out there. Whereas Amazon is not really so much a web company. Like if they want to make a big impact on the web, probably the product they did is the best way for them to do, because they can sell your device and on their device you can use this. We have kind of bigger ambitions, since as a non-profit foundation, our goal is really not just to move our products forward, but to really move the entire web forward. So really the short answer is that things like Speedy and offline caching of apps, I believe is going to give you a lot more improvement over the long time than some like local-based or server-based caching. Does it make sense?
Understood.
Okay. Any additional questions? Okay. Let's resume the presentation then.
Okay, cool. Do you wanna?
Sure, I
wanna
can
do it, or
I can do a couple of these.
Sure. I think this is device storage.
Oh, okay.
Yes.
Actually, yeah, you can do this.
Okay, yeah, so another example of a privileged API that comes in handy if you want to write a gallery app or a music app or something like that where you where you want to kind of store data in a way that is accessible by other apps, or for instance the USB connection. So if you plug in the phone and then people put their MP3s and their videos on the phone, and then you want to be able to read that as an app, or write the camera wants to be able to write pictures there so that later when you synchronize it with your PC, it's available over USB. And for various reasons, it doesn't really make a whole lot of sense. One of them is for security. It doesn't really make a whole lot of sense to expose just the whole file system like you have on some other systems. But what you really want is you just want to have some sort of storage where these files exist. And so this is what device storage is for. And then every app, like even every website, on top of that, they can do their own storage of files if they want to. But those files will only ever be available to that app. And there's a quota on it. I think it's something like 5 megabytes initially. But a lot of people a lot of developers basically come to us and say, like, oh, my app needs to write files to the device, and then often what they really want is they just want to be able to cache data, like an audio streaming app wants to be able to cache data, but no other app really needs to have access to that. So device storage is not really useful for that. So for those sort of things, or when you have a newspaper and you want to cache PDF content or any kind of content locally, you have a music app, you have a video app, you want to cache things. For those sort of applications, IndexedDB is a really good way to cache files. And in fact, when you say I want the abstraction there is called a blob. And when you say I want to store it as a blob, it actually gets stored as a file, and you can stream it straight from the file system, and it's very efficient. And so but if you do want to, for instance, if you're writing a camera app, and people do this, I mean, people have written much nicer camera apps for instance, the iPhone and stuff, and you want to be able to synchronize it with the PC. This is how you can do it: camera video app, or go the other way around. If your app expects files that are dropped in from the computer over USB, then device storage is the way to go. Orientation API, super useful, depending on if you want to do certain things, depending on the orientation of the device. Now the interesting bit is a lot of this can be done using CSS, etc. If you want to lay out the page differently, or lay out the app differently, show different things. And you don't even need to write JavaScript for a lot of these things. But one interesting bit is if you want to actually lock the orientation. So a lot of apps want, they'll prefer to be only workable in one particular orientation. I mean, a really good example, for instance, is the home screen, right? The home screen should not rotate, and I'm sure you can think of many other applications. I mean, probably like certain games, you don't want to be able to rotate the app, and so. So here's a way to lock the orientation in one place, and then another privileged API is I think no, this one is not privileged. So we have basically an API that is unprivileged if you want to be able to find out sort of what your current bandwidth is thereabouts. It doesn't it explicitly doesn't tell you whether you're on 3G or Wi-Fi or something like that, because that should not be something that any web app should be able to read. But if you're privileged, you can find out that information. But to most apps, it should just be known whether, what is your approximate bandwidth, and are we on a metered connection, i.e. is the user paying for bandwidth or not. And so there's a lot of other APIs here that are basically very sort of tuned to a phone. Keyboard, for instance, if you want to manipulate and artificially manipulate the keyboard. We talked about the WebApps API, and I think this is, and so we come to the permission stuff, which is, we sort of talked about it already. So all of the privileged APIs are basically require you to be a packaged app, and if you don't require any of them, then you can self-host. You can self-host the code, and it's much more like a regular web page. And you can still use things like local storage, IndexedDB, offline cache for storing things. You can still access stuff like the camera, etc. Using web intents, though. We talked about, Andreas this morning talked about the updates. I think that has been sufficiently answered, but please feel free to ask any questions. Okay, I think that is in terms of the APIs.
Maybe you want to switch to the development environment, right?
Yes.
Right, so I will talk a bit about the developer environment in a moment. First, I wanted to answer a question that came up during lunch.
Yeah, oh yeah, also do the mic.
Switch the microphone again. All right, so one question that came up during lunch, I'm not sure whether the person who asked the question is still in the audience here. Actually, you were, yeah.
Yes.
So you want to ask a question again?
Yes. How will you occur the update process of gonks?
Yeah, so the question is centering around how the update story that we explained to you is affecting Gonk. And so I mentioned previously during the talk that the Gonk piece is the kind of very foundational piece that we, the OEM and the chipset maker jointly create. And we have basically a basis for Gonk that we give them as kind of a starting point. But Gonk, the very bottom part that includes the kernel, contains a bunch of like proprietary things like device drivers that are not necessarily open source, and the OEM creates them. So when then it gets updated, we're using the same mechanism that is used today for smartphone updating. Because you take the entire system, you have to override the entire flash software on the phone to change the Gonk system. And I explained earlier, our goal really is to never have to update Gonk. Gonk is basically part of the hardware. When a device is manufactured, the OEM makes device drivers in a kernel, puts them on the device, and the only time we have to exchange that if there's a major fault in the software, like the kernel is insecure, or maybe the graphics driver crashes all the time. So these kind of things get taken care of as a traditional update. Everything else, we can separately and much easier update the web engine, the Gecko part, and the actual apps themselves can be updated, even up to the point that they can basically be live, linking to your server. Now the question that came up over lunch is, all the things we talked about today, all the features, like the web APIs, for example, we just talked about, where they really sit. Are they in part of Gonk or are they part of Gecko? Because that really affects how often we can update the system. And actually, all the things that we just talked about the last hour or so, all the web APIs, they're all completely part of the Gecko system. So it's very easy for us to update them. So we can offer feature updates if there's new APIs, if there's new features for WebGL or new HTML5 extensions. You can very easily roll out a new version of the web engine. The download size of those updates actually is very small. So compressed, the Gecko engine itself, if it's a full update, if you're not trying to do any differential compression, it's around 8 megabytes. So you can very easily swap out the web engine on these devices. And we can deliver a new set of features and HTML5 capabilities. This is pretty important to combat fragmentation. The reason that Android is so fragmented is that it's very, very hard to port onto an existing device a new version of Android. And also, as Android is like moving further up the hardware ladder, many of these old devices simply cannot run a new version of Android. And the web is really not developing the same way. If you look at Firefox, for example, Firefox Desktop works just fine on really old Windows XP machines. the web tends to be an environment where a lot of people have older hardware, and we are not really targeting only future hardware, we are also targeting existing hardware. So our goal is to keep the existing phones alive for a long period of time, and we can deliver feature updates. Basically, the only thing that's needed there is that the carrier and the OEM do some testing to make sure the new version of the web engine still works with the existing hardware that they have given customers. Does that answer your question?
Yes.
Okay.
You're working on some maps or geolocation APIs?
Yes, so geolocation actually is already an existing API in the web. So there's an API you don't even need a special permission bit for. You can ask for the current location of the user. There's a little like consent door hanger that comes down where the user can say, I'm okay with that. So you can ask location, and you can ask for compass headings already as well. And these parts are simply part of the web platform already. And in the devices, there can be a closer tie-in to additional data services. So we can do location based purely on GPS, or depending on the device, there might also be a component that will use the Wi-Fi environment and some database lookups for a service to kind of give you a more precise fix on your location. Now on the map side, our goal is when we ship these devices, we will have a Maps app on them most likely. We don't consider the core app right now. So we are talking to various maps providers, and there's like 3 or 4 of them. And our goal is to have on these devices basically one of these map applications installed. Any additional questions?
So for these device APIs, we have an option in terms of emulation desktop to simulate the calls for things that are not there in the desktop, like the telephone, SMS.
So actually, Philip is going to talk about quite a bit of this here towards the end of it. So I will talk first about the more kind of the high-level, easy ways to emulate the stack here. And then we also have a more deeper emulation where we actually use a device emulator. And there you can simulate incoming SMS, incoming calls, these kind of things. We'll probably not spend as much time on that today, to be honest, because that's kind of like very few people on this planet will have to simulate incoming calls. It's a radio stack, because most people will probably not spend their time writing medallions. Most people will spend their time on like the more kind of high-level APIs that we're about to talk about.
Like SMS?
SMS, that's probably a more popular one, yeah. So we would expect more SMS applications than actually the radio side of it, right? So I'll go to the slides.
Sure. Excuse me.
Oh, yes. Yes.
Is it possible to call another application from one application, like, for example, a single sign-on phone, an app for Facebook, for example?
Yeah.
Would be possible?
So there's kind of 2 ways you can do that. So if it's an installed app, you can send an intent. So applications can install themselves and say, like, I know how to react to this specific intent. So for example, we have a PDF viewer application on this device, and the PDF viewer uses a JavaScript and HTML implementation to display PDFs. And the viewer itself, if you call the viewer directly, it's not particularly useful. It's going to like start and ask you to like pick a document, right? So usually you want to view a document from somewhere else. And in addition to this, when the viewer installs itself, it installs an intent saying that I know how to handle the MIME type octet stream PDF. And then the email application, when you click on an attachment that has that MIME type, it will send an intent like, hey, who knows how to handle this MIME type? And that's going to basically swap in the PDF viewer application and automatically start displaying the document to you. So this actually works very similarly the way you would expect it in other smartphone platforms.
Well, on Android. On iOS,
On
iOS is
yeah,
actually
iOS
pathetic about
iOS is it's more locked down. Like Android at least try to be more open. So many of the APIs you see here, by the way, we try to be innovative and creative, but in many cases also, if there's existing good solutions, we copying and adopting them. So if this Intents, for example, it's a really good system, it's really extensible, people really like it. There's no reason to invent something different, just to be different. So in many cases when the APIs as well. So some of these APIs you see here, they're actually very similar to what APIs PhoneGap has proposed, or VAC, which is a group of operators and OEMs that have been working on device APIs. So whenever we make these new APIs, we try to see what is out there. And maybe there's already a solution that's almost good enough, and all we have to do is kind of tune it a little bit, and then we can make it work.